All right, so today we start with the mean value theorem. What's mean mean? What's another word for mean? Average. Okay, so it's kind of the average value of a function between two places. Okay, so to do the mean value theorem, there's two components. You got to basically find the slope and then set the slope equal to the first derivative. And then that's how you find the mean value. Okay, so we got to do the slope formula. So to do the slope formula, it's f of b minus f of a over b minus a, where this is a and this is b. Do you get that? Okay, so if we find f of 3 minus f of 0 over 3 minus 0, what is f of 3? Well, it's 3 cubed minus 6 times 3 squared plus 12 times 3. Calculators, go. You're probably going to need a calculator today. I don't know. No, it's sophomores. What? This is 9. Okay. F of 0 is 0 cubed minus 6 times 0 squared plus 12 times 0, which is 0. So you get 9 minus 0 over 3 minus 0, which is 9 over 3, which is 3. But that's not the mean value. You have to set the first derivative of x equal to that number. Okay? So the first derivative is 3x squared minus 12x plus 12 equal to 3. Okay? So what can we do to both sides? Divide everything by 3. So x squared minus 4x plus 4 equals 1, right? Move the 1 over. X squared minus 4, come on, Mr. Bierschbach, minus 4x plus 3 equals 0. X minus 3, x minus 1. So x equals 3 and 1. So if we look at 3, 3 is at the edge of the interval, and 1 is in the middle of the interval. So it would be assumed that 1 would be the mean value of that function. I'm thinking now because I can't remember, because I think it has to be, if it's between the interval, the answer has to be between 0 and 3 there. But I'm not remembering for sure. Now, what you guys have to do isn't that whole process. Okay? You guys only have to basically go this far with it on Khan Academy. But you have to understand how to do the rest of it, basically. But where x is 3 and x is 1 will give you the mean value of the function. Okay? So 9, if we put in a 1, 1 minus 6 is 5 plus 12, negative 5 plus 12 is positive 7. Because 3 would give you 9. I think 7 is the mean value of this function. All right. So we're not going to do that whole thing. We're just going to figure out what C is. Okay. Oh. Yeah.
where do we get the 3 from?
The 3 comes from this part.
So we still have to do that part. Okay, because you just made it sound like. So we do have to do all this.
You don't have to figure out what the actual mean is.
Oh.
You just have to get the first derivative equals
the number.
Yeah.
But then you wouldn't have to do.
So you wouldn't have to do that stuff on the bottom end.
I guess you could still have equals the number.
All right, let's do this one. See where it leads us. Okay?
Sure.
What's f of b here? That would be f of 13, which if we stick 13, 3 times 13 is 39, minus 3 is 36. The square root of 36 is 6. F of a is f of 4, which is the square root of 3 times 4, which is 12, minus 3, which is the square root of 9, which is 3. So it's 6 minus 3 over 13 minus 4, which is 3 over 9, which is 1/3. So we stick the square root of 3. Oh, yeah, we do have to solve for this. So yes, that was what we had to do. So we did have to find one. Sorry, I had to remember. But since 3 is on the edge, we do not use the edge numbers because it has to be between the open interval for it to work for the mean value theorem. Okay? But we use the closed interval numbers to find it. Sorry, that doesn't make a lot of sense, but okay. So what's the first derivative of this bad boy? Well, h of x, and I've been putting f of x, but h of x equals 3x minus 3 to the 1/2 power. So the first derivative is 1/2 times this to the negative 1/2 times 3. Okay? So it's 3 over 2 square root of 3x minus 3 equals what we got on the first part, 1/3. Now how do we solve that? Where do we get what? The 1/3 from doing this.
Where do we get the 2
Okay, the 1/2. The 1/2 comes out front, and then we take it times 3. And that's what the 3. Yep. So, if you have 2 fractions, you cross multiply. 3 times 3 is 9 equals 2 square root of 3x minus 3. If we square both sides, 81 equals 4 times 3x minus 3. Distribute. 81 equals 12x minus 12. Add 12. 93 equals 12x. Divide by 12. X equals something like 7.75. Try that. Okay. I knew the answer. Sorry. I cheated. Okay. Below is Uriah's attempt to write a formal justification for the fact that the equation, the first derivative equals 8, has a solution somewhere between 1 and 3. Is the justification complete? So, they say that this function is differentiable and continuous, so it has a derivative, so you can take a derivative of it, and it's in between the endpoints. So they found h of 1, h of 3, did the math to get 8. So if they set the first derivative equal to 8 and found a solution, is that correct? Or did they not establish something? Is their justification complete? Or did they not establish the rate of change? Or did they not establish that it's differentiable?
Well, they established that it's
Yep, right there. And then the rate of change was right there, so it is complete. Okay, let's look at one that's not complete. Can we use the mean value theorem to say the first derivative of this equals 16, somewhere in between that?
It's not differentiable. Oh, actually, no, it's speed. 16 doesn't go in there.
Since the average rate of change, well, let's look at it. What's 2 to the 5th power equal to? Nope, too big. 32. 2 to the 3rd power? 8. So 32 minus 8 over 5 minus 3 is 24 over 2, which is 12. They said 16. That's where they went wrong. Okay, on this one, now they give us a table. They say, well, between these two, okay, the first derivative is equal to 40. You set the first derivative equal to 40. Okay, so what is 230 minus 110 over 0 minus negative 3? Which equals? So that part of it's right. Did they say that it was differentiable? No, they only said it was continuous. They did not say it was differentiable. So since they did not say it's differentiable, that one's a no because they didn't state that. Unlike, oh, I thought I had another one. Doggone it. I thought I had another one on here where they did say differentiable up here. It's basically the exact same thing, but they said continuous and differentiable. If it's continuous and differentiable and they get the right number here, then both conditions have been met. Okay? So you'll have just a couple assignments over this stuff and then a quiz today.